In this video, we are going to talk about how we can sketch simple graphs that have holes. So let's get right into an example. I want to sketch the curve, state the domain and range, find and label any relevant points like intercepts, if there's a vertex or anything like that, hole, label those. So I have this equation here. I have y equals this fractional function. And the first thing I'm going to do is try to simplify it. So the denominator already looks pretty simplified. On the numerator, I see I have a quadratic, and hopefully that quadratic factors. So I'm going to try to factor it. I know I'll have an x, and then something, and then x, and then something. In fact, I want to give you a chance to pause it for just 30 seconds. Remember, what we're looking for is two numbers that multiply to 12, and they add to -8. So give it a quick pause in 3, 2, 1, and see if you can find those numbers. Okay, so hopefully you did that. So the numbers that work are -2 and -6. And now that's nice because there's a common factor on the top and the bottom, which we can divide away. So we can divide that away, and that'll leave me with a 1 and then a 1. So overall, I'm left with x minus 6. And I want to keep in mind, I had this fractional function. Do I have any domain restrictions? And specifically, I see that, there was this x minus 2 on the bottom, and that kind of disappeared through the cancellation. So when it cancels like that, I do want to remember that, wait, x better not be 2, because that was making that original denominator 0. So next to my simplified form, I'm going to put a comma, and then say x doesn't equal 2. So that's what it simplifies to. So what is the graph of this going to look like? I'm first going to just graph, what is just y equals x minus 6 without this domain restriction? Well, this is the equation of a line, right? The -6 is the y-intercept. So there's a y-intercept at -6. And then the slope is 1. There's technically a 1 in front of this x. So I'm going to draw an upward sloping line going through that y-intercept. It's got a slope of 1, so something like this. Okay, so I got this. I can find the x-intercept. So I can find my x-intercept by setting y equal to 0. So to do that, we set y equal to 0 in the equation. And that gives me 0 equals x minus 6. And if I isolate x, we get x equals 6. So that's my x-intercept. My x-intercept is going to be at 6 here. Okay, so if there was no domain restriction, that's what my graph would look like. So now let's try to do it with the domain restriction. So if I have y equals x minus 6, but comma got this domain restriction that x better not be equal to 2, how is that going to impact the graph? Well, I'm going to start off by drawing the same shape, but once I get to where x is 2, I'll have to be careful. So I'll have this line shape here, but once I get to x equals 2, I have to skip that because I cannot plug 2 into this, and then I keep going after that. I keep going. So because I end up skipping just that one point, what that absence of that one point does is it creates a hole in the graph. So I have this hole here. And, I know the x coordinate's 2. To get the y coordinate, we can plug 2 in to this simplified form. And if I do that, we'll get that the y coordinate is 2 minus 6, which is -4. So that's the y value of the hole. Okay, so I got where the hole is. We have our intercepts. They were already labeled for us. In fact, it's good practice now to write them as ordered pairs. So the y-intercept is at 0, -6. The x-intercept is at 6, 0. Those are my intercepts. So at this point, I have the graph. I've labeled relevant points like intercepts. This has a hole. And then it wanted domain and range. So let's write those. And then I think we got this. So domain, my x values. Well, if I look at the graph, x can be anything except 2. 2 gets skipped, and then I keep on going. So my domain is -infinity, onwards to 2, union, and then 2 onwards to infinity. I can also see that from the original formula, because the only restriction was x is not equal to 2, so the domain should be everything else except for 2. My range, my y values, the y values, I'm skipping -4 because I have this hole here, but anything below -4, I hit that y value. Anything above -4, I also hit those y values. So the range is -infinity until -4. I'm going to skip -4 and then go onwards to infinity. And I think we got it. We got the graph. Whoops. We got the graph of our function. We got the hole. We got the domain, the range. And that's how we do it. So the key takeaway is if you have a fractional function and there's a factor like this on the denominator that cancels away completely, well, it gives you this domain restriction. And when you draw the graph, the fact that that x value gets skipped is going to create a hole in the graph. So to end, I want to give you a practice problem to try. So try this one here. I'll leave it to you to pause it for at least 3 minutes to try this. But we will talk about this one together in class.